Well, my students, we can start discussion of the interpretation of NMR spectrum. I shall give one by one. First compound, that is CH3, single bond CH2, single bond O, single bond CH3. Right? That is ethyl, methyl, ether. Ethyl, methyl, ether. See how many signals it gives. First you calculate the number of types of protons. See, this is oxygen, an electronegative atom. And if you consider this as A set, the chemical environment of the three protons, they are similar and it is different from CH2. Right? And this is A set. See the chemical environment of these two protons, it is nearer to oxygen and it is away from this one, and hence the CH2 protons are similar and the chemical environment of these two protons, are different from CH3, right? So we can label it as B set. What is the chemical environment of these three protons? Whatever be the chemical environment of these two protons, the chemical environment of these three protons are also similar because they are equidistant. Therefore, this also B. Am I right? This also B. Now, how many signals it gives? It gives two signals. It gives two signals due to A set and also B set. And what is the signal intensity? What is the signal intensity? Intensity ratio A is to B. A, that is formed from 3 protons, and B, that is formed from 5 protons. Therefore, A is to be equal to what? A is to be equal to 3 is to 5. Right. Now see the position. Which one will be nearer to the TMS? Which one will be more shielded? See, the B set, nearer to B set, there present an electron withdrawing oxygen. Therefore, electron density around the proton is smaller. Therefore, this is de-shielded. But this proton, they are more shielded because oxygen is far away. Oxygen is far away from the CH3 protons. So, which one is more shielded? More shielded. More shielded. That will be A set. And less shielded will be B. Right? And when you take the spectrum, NMR spectrum under low resolution, when you are taking the NMR spectrum under low resolution, in which way it will appear? See this. This is the NMR spectrum, where intensity is plotted against a chemical shift. Chemical shift is del 0 to 10, and first of all you draw a sharp signal at 0 due to TMS. Right? Then nearer to the TMS signal, you draw more shielded protons. Which one is more shielded? A. A is the A signal due to A, that is obtained from 3 protons. So you draw a signal this way. You draw a signal. Right? Now B set, that is from 5 protons. Therefore, signal high intensity will be much larger. Right? Now you connect using noise. This is the noise. This is the signal, this is the noise. Therefore, this is due to A set and this is due to B set. A set is formed from 3 protons and B set is formed from 5 protons. So, this is known as the low resolution spectrum. Right? Now, you consider a high resolution spectrum. When you consider a high resolution spectrum of the compound, you know this CH3, this is the TMS signal, TMS that you will be getting as a sharp signal under high resolution, and after that you are getting the signal due to A. Nearer to A, how many protons are there? You forget about the oxygen. These are the neighbors. Right? For the time being, you need not consider the B. You take only the immediate neighbor. What is the immediate neighbor? Immediate neighbor is B. Therefore, the number of subsignal for A, this is the signal of A, low resolution, that will be splitted into a multiplet, right, due to the interaction of the neighboring proton. What is its neighbor? Neighbor is B. Neighbor is B, right? How many protons are present in the CS2 group? 2. So how many neighbors it has? CS3 has 2 neighbors. So what is the n value? N value is 2. So n plus 1 rule, 2 plus 1. Therefore, this signal due to the CS3, that will be changing into a triplet. That will be changing into a triplet with intensity ratio. We already studied 1:2:1. If it is a triplet, it will be 1:2:1. In that way, we are getting the triplet. Therefore, this is the normal signal for the CS3 under low resolution, but under a high resolution or high resolution, the signal will be changing into a triplet with the intensity ratio 1:2:1. So this becomes the A. Now see the B. For the time being, you need not consider this B because it is little away from oxygen, right? Though it is B, for the time being you need not give much gravity. Now you consider the B signal. B signal, that is a larger signal because it is a contribution from 5 protons, right? Now in order to get the multiplicity of B signal, you calculate the number of neighbors. Which are the neighbors of the CS2, CS3? So these are the neighbor. This becomes the neighbor. Due to the neighboring influence, the signal will be splitted. So this signal will be splitted into what? Into a multiplet. How many subsignals are getting in this multiplet? In order to calculate the number of multiplet or subsignal for this signal, you calculate the number of neighbors. What is the n value? N value equal to 3. N plus 1 rule, 3 plus 1. 3 plus 1 is equal to 4. Therefore, this signal will be changing into a quadrat. This signal will be changing into a quadrat. When you take the Pascal's triangle, intensity ratio becomes 1:3:3:1. See the height. This is 1, 2, 3. Therefore, 1:3:3:1. This is the B set. This is the high resolution spectrum. So, in the low resolution, this was the appearance. Right? This was the appearance. But under high resolution, these signals will be changing into multiplets. Sometimes you are getting singlet, doublet, triplet. That depends on what? Depends on the number of neighboring protons. Always remember, multiplicity, formation of subsignal depends on the number of neighboring protons. This way, the high resolution spectrum will appear for this compound. I hope you got it. Now you take another example. That is CH3 single bond CH, 2 single bond CH2, single bond Br. You take this compound. You calculate the NMR spectrum under low resolution and also high resolution. First of all, you label the protons: A proton, B proton, C proton, because they are under different chemical environment. The chemical environment of these 3 protons are different from the 2 protons. The chemical environment of these 2 protons are different from these 2 protons. Both the 3 protons are under different chemical environment. How many sets of protons are here? 3. Right? So how many signals we can expect? We can expect 3 signals. Why we can expect 3 signals? Because they present 3 sets of protons. That is A set, B set and C set. Right? What is the intensity of the signal? Second is intensity. Intensity depends on what? Number of contributing protons. A signal, that is from 3 protons. B signal from 2 protons. And C signal from the 2 protons. And the position of the signal. Therefore, A is to B is to C. What is the intensity ratio? That is 3:2:1. Right? Out of the 3 sets, you look at the position of the signals. Which one will be nearer to the TMS? More shielded. More shielded means having more electron density. And there is an electron withdrawing group, bromine. And that electron withdrawing group withdraws the electron density around the proton. And hence, this methyl group that is having larger electron density So this is more shielded. This will be least shielded. This is less shielded. Therefore, you are getting the position of the signal. The A set will be seen nearer to the TMS. We can write A will be seen nearer to the TMS, and C will be seen far away from TMS. Am I right? It is far away from TMS. Why it is far away from TMS? Because there present an electronegative bromine nearer to the C protons or C set of protons. Right? Now, we can write the low resolution spectrum. Low resolution spectrum. When you draw the low resolution spectrum, first of all you draw intensity, then you draw delta, here 0, here it is 10. First of all you draw TMS signal, TMS. Then you draw the most shielded is CS3, and it is a contribution from 3 protons. Therefore this way it will appear. Right? Then comes B, less shielded, contribution from 2 protons, height will be lower. And C, least shielded, contribution from 2 protons. See the signal, the intensity of the signal. After that, join using noise. Right? This way the low resolution spectrum will appear. So this is due to A set, this is due to B set, this is due to C set. A set is formed from 3 protons, and B set is from 2 protons, and C set is from 2 protons. Right? Now you take the high resolution spectrum. You take the high resolution spectrum, that is the multiplicity of the signal. Multiplicity depends on what? In simple way, multiplicity of a signal depends on the number of neighboring protons. You are well aware of that. Now you draw the high resolution spectrum. In the high resolution also delta value varies from 0 to 10. 0 to 10. By whatever be the field or whatever be the radiation that we are giving, chemical shift is independent of these matters. Either the field or the frequency. The field, it is not field dependent or frequency dependent. It is not field dependent or frequency dependent. Remember that. Now, the CS3 signal, this is the TMS signal at 0. That is a sharp signal. That is followed by CS3 signal. Nearer to the CS3, there present 2 neighboring protons. So these 2 neighboring protons causes the splitting of the signal into what? Into n plus 1. What is n? N is 2. Right? So signal due to CS3, that will be changing into a triplet. That will be changing into a triplet due to the presence of these 2 neighboring protons. Right? Now that is followed by B set. As far as the B set is concerned, and the B has got 3 plus 2 neighbors. 3 and 2. 5 neighbors. So these 5 neighbors will affect the signal of the CS2 protons, right? So the signal of the CS2 protons, that will be splitted into a hextet 5 plus 1. Number of neighbors 3 plus 2, 5. So it will be changing into a hextet. That will be changing into a hextet. In that way it will appear. And you consider the signal intensity is obtainable from Pascal's triangle, where you apply n is equal to 5 or r plus 1 raised to 5. You expand it and just get the coefficients. In that way it will appear. Now you take the CS2. The CS2 proton, that is the least shielded one, that will be appear far away from TMS. Right? This CS2. And this CS2 signal, now signal due to the CS2, how many neighbors it has? 2. Therefore, these 2 protons affect the signal. These 2 protons will split the signal into what? Into n plus 1. What is the value of n here? N always represents the number of neighbors. As far as these 2 protons are concerned, these are the neighbors. Number of neighbors is equal to 2. So n plus 1 equal to 3. Therefore, signal due to the CS2, C signal, that will be changing into a triplet. So this is the appearance of the compound. This is the NMR spectrum of the compound under high resolution. So earlier this was the signal. This was the signal due to A set. This was the signal due to B set. This was the signal due to C set. Right? But under high resolution, each signal will be further splitted. The number of subsignal in a signal depends on what? Number of neighboring protons. Number of neighboring protons denoted by n, where you are applying n plus 1 rule, and the coefficient of the expansion r plus 1 raised to n gives the intensity of the subsignals. Right? In the next video I shall give more examples.